Hello everyone, welcome to Alfonso Academy. I am Sir Peter Alfonso and this is the 7th part of chapter Gravitation. Hope you have seen the earlier 6 parts of this chapter. If not, then I have placed the links of those videos in the description of this video. So in this part we are going to study about gravitational potential, energy, escape velocity and weightlessness in space. So in standard 9th you had studied about potential energy. The energy stored in the object because of its position or state is called as potential energy. So it was given by potential energy equal to mgh, where m was the mass of the object, g was the acceleration due to gravity which was considered to be constant 9.8 meter per second square, and then h was the height of the object from the surface of the earth. In fact, you had derived this formula in standard 9, potential energy equal to mgh, and it was largely dependent on the height of the object because mass of the object and the acceleration due to gravity was considered to be constant. So it was dependent on the height of the object, and as the height increased, potential energy increases. So as the height increases, potential energy increases. So this is the first thing which you have to remember, because we are going to get a new formula for potential energy, gravitational potential energy. So in short form it is called as GPE, gravitational potential energy. So we are going to get a new formula. So first thing which you have to remember is, as the height is increased, potential energy increases. Now in the last few parts you are studying that as the height increases, g also varies. The value for acceleration due to gravity, the small g, also varies. It decreases as the height increases. In fact, you had taken few examples in your last part. You had taken an example of a man-made balloon reaches a maximum height to 36.6 kilometers from the surface of the earth. Its acceleration due to gravity is 9.77 meter per second square, and as you go further up, weather satellite which is launched at the height of 400 kilometers from the surface of the earth, its acceleration due to gravity, the value for acceleration due to gravity on that weather satellite is 8.7 meter per second square. And then if you go on further heights, it goes on decreasing. The value for acceleration due to gravity goes on decreasing. We have taken one more example of a communication satellite which is launched at the height of 35,700 kilometers from the surface of the earth. Value for acceleration due to gravity on that communication satellite is 0.225 meter per second square. In fact, if you go on very large height, the value for acceleration due to gravity approaches 0. And at certain time, when this height is at infinite distance, the value for acceleration due to gravity becomes 0. So g is equal to 0 at infinite distance. So at infinite distance, the value for g, value for acceleration due to gravity, turns out to be 0. So if g is 0 at infinite distance, definitely potential energy will be 0. G will be 0, then potential energy will be equal to 0. So at infinite distance, potential energy for any object is 0, because value for any object, value for acceleration due to gravity for any object is 0. So G is equal to 0, potential energy equal to 0. Now you have to remember the first thing which I told you to remember. Potential energy increases if heights are increasing. If height is increased, potential energy will increase. If height is decreased, then potential energy should decrease. So if you consider this point at the infinite distance, where potential energy is 0, and then move the object from this point to a lesser height, to this point where the height is less compared to the infinite distance. So if height is decreased, height is lessened, then automatically potential energy will decrease. Because height is increased, potential energy increases. Height is decreased, potential energy decreases. So if the object moves from this infinite distance to a lesser height, to a point over here, that means height is decreased. So potential energy will also decrease. So here the potential energy is 0. What will be the value for potential energy to a lesser height? It will be less than 0. Less than 0 means what? It will be a negative value. It will give a potential energy a negative value. So potential energy is negative at this point and lesser height. So the value for potential energy goes on decreasing as the height decreases. So now it is clear why we are getting this negative sign for gravitational potential energy. It's because potential energy at infinite distance is 0, and as the height decreases, potential energy decreases. That means it becomes less than 0. Less than 0 is nothing but negative. So we are having negative value for gravitational potential energy. Now we will see how we are getting this formula. Potential energy equal to mgh, g is equal to gm upon r square. We had derived this formula for acceleration due to gravity in the previous part. So substitute this g over here in potential energy. We'll get it like m into gm into h divided by r square, where r is the distance of the object from the center of the earth and h is the distance of the object from the surface of the earth. So difference is the radius of the earth between h and r. Now next we are taking as r as almost equal to h. So we are taking it as equal and we are cancelling one of the r with h. Now you have to know the difference between r and h very well. So r, small r, is the distance of the object from the center of the earth. So if you consider the object at this place, so this full distance till the center of the earth is small r, and h is the distance from the surface of the earth till the object. So there is not much difference between small r and h, because radius of the earth seems to be smaller in front of this full distance, and it is considered to be as negligible, and the r is cancelled with h. So r and h gets cancelled since they are almost equal. So we are getting final formula as gmm upon r. So we can put a negative value for this. So this is actually the final formula. Again, r is nothing but capital R, which is the radius of the earth, plus the height. So r plus h. So again, by substituting r plus h instead of r, we are getting this as the final formula. So this is the formula for gravitational potential energy, which is the general formula for gravitational potential energy. So whatever I have explained, I have written over here. So when h is small compared to the radius r of the earth, we can assume g to be constant and can use the formula mgh. But for large values of h, the value of g decreases with increase in h. At infinite distance, Earth's gravitational force does not act on the object. So value of g is 0. So value of potential energy is also 0. Thus, for smaller distances, that is heights, the potential energy is less than 0. That is, it is negative. So when an object is at height h from the surface of the earth, its potential energy is minus capital G, capital M, small m divided by r plus h. Here m and r are the earth's mass and radius respectively. We have seen that whenever the object is thrown up, its velocity goes on decreasing because of the gravitational force of the earth, which acts towards the center of the earth. So whenever the object is thrown up against it, its velocity goes on decreasing, and to a certain height the velocity of the object becomes 0. So that is the maximum height which the object attains, and then the object starts falling down towards the center of the earth or the surface of the earth. So the maximum height which the object travels, which the object reaches, depends on the initial velocity given to that object. Now by Newton's third equation of motion, v square equal to u square plus 2as, where v is the final velocity of the object at the maximum height. So v is equal to 0, then u is the initial velocity given to the object. A is the nothing but acceleration due to gravity, which acts against the direction of the object. So the value for acceleration due to gravity we are taking as negative, because object is traveling against the acceleration due to gravity, which acts towards the center of the earth in the opposite direction. So, and s is the distance to which the object travels, or other words we can call it as the height to which the object travels. So v we are taking as 0, a we are taking as negative g. So u square plus 2 into negative g. So this becomes minus 2gs. Oh yeah, minus 2gs. Then this minus 2gs you can take the other side, it will become plus 2gs. U square will remain the same side. So 2g comes in the denominator of the other side. So s is equal to u square divided by 2g. Now if you see this formula, as u increases, s will increase. That means the maximum height reached by the object depends on the initial velocity given to that object. Thus, higher the initial velocity u, the larger is the height reached by the object. This is possible because the object is able to oppose the force of gravity because of the initial velocity given to that object. Now one more thing which I had studied, as you go on to greater heights, the value for acceleration due to gravity goes on decreasing. That means the force, the gravitational pull of the earth goes on decreasing on the object. So if you keep on giving the object the initial velocity, more and more initial velocity, then there might be a time that the object will overcome the gravitational pull of the earth completely, and it might escape the gravitational force of the earth, and it might not come on the earth's surface back on the earth's surface anymore. So this velocity which is given to the object to escape the gravitational pull of the earth is called as escape velocity, and we can determine its value by using law of conservation of energy. The object going vertically upwards with initial velocity equal to escape velocity escapes the gravitational pull of the earth, but the gravitational force of the earth or the gravity of the earth becomes zero only at the infinite distance. That means the object has to reach the infinite distance in order to get free from the gravity of the earth, and that is the place where the object will be on rest. So for any object of mass m on the surface of the earth, h will be equal to 0, height will be equal to 0 on the surface of the earth. The kinetic energy is given by the formula half mv square. So v over here is escape velocity, so half mv escape velocity square. The potential energy, we had derived the formula earlier, minus gmm divided by r plus h, but value for h is 0, so in the denominator it's only r, which is the radius of the earth. So total energy is given by kinetic energy plus potential energy. So total energy we are taking it as E1 half mv escape square, which is escape velocity square, minus signs comes from this gmm divided by r. So this is E1, value for E1. Now at infinite distance h will be infinity, it will be infinity. So kinetic energy will be equal to 0 because object is at rest at infinite distance, and then potential energy equal to minus gmm divided by r plus h, but h is infinity, so r plus h is also infinity, so anything divided by infinity is equal to 0. So 0 plus 0 will be the total kinetic energy E2. Now law of conservation of energy. Energy can neither be created nor it can be destroyed, but it can be converted from one form to another. Total energy in the universe remains constant. That means the energy on the surface of the earth, E1 will be equal to the energy at infinite distance, equal to E2. So E1 equal to E2 by law of conservation of energy. Now substitute the value for E1. This value will come in the left hand side, right hand side will be 0 because E2 is equal to 0. Then take the minus gmm divided by r on the other side, it will become positive, and then take 2 in the numerator of the other side. M and m will cancel, the mass of the object will cancel with the mass of the object on the other side. Then v escape velocity will be root of 2gm divided by r. Next we have to multiply and divide this term in the square root by r. So when we multiply and divide it by r, we'll get r square in the denominator. So 2gm r divided by r square, and gm divided by r square is nothing but acceleration due to gravity, g. So we can replace that gm divided by r square with g. So you will get the value for escape velocity as root of 2gr, where r is the radius of the earth. Now you can substitute the values and find the value for escape velocity. So g is nothing but 9.8 meter per second square, r is 6.4 into 10 raised to 6 meters. So 2 into 9.8 is 19.6, and 19.6 into 6.4, if you multiply that you will get 125.44, and this 10 raised to 6 will come as it is. So next you can remove the decimal point so that it is easy for you to remove the square root of a number. So you can remove this decimal point by multiplying by 100. So 100 from this 10 raised to 6 will come to this number. So it will become 12,544, and 10 raised to 4 will remain. You can separate out the square root sign so that it becomes easy for you to remove the square root. So square root of 10 raised to 4 is nothing but 10 raised to 2. and then square root of 12,544. Now in the previous videos I had told you how to remove the square roots. So this number is slightly more than 10,000. So square root of 10,000 is 100. So then you can try 110 square root, square of 110 will be 12100, 12,100. So this number is slightly more than 12,100. Next you can try 111, 112. So you can see that there is 44 over here, and 12 into 12 is 144. So the last two digits are 4 and 4. So if you try this 112, you will get the square root of this number as 112. So 112 into 100, 10 raised to 2 is nothing but 100. You can multiply that, you will get 11,200, and unit for velocity is meter per second. And then if you want to convert it to kilometer, you have to divide that number, the meters, by 1000. So if you divide this by 1000, you will get that as 11.2, and then it will become kilometer per second. So escape velocity equal to 11.2 kilometer per second. Now the spacecraft which we launch on the moon or on the other planets have to have their initial velocities larger than this escape velocity to escape the gravitational pull of the earth and to travel to those objects. So next we will see the escape velocity on the surface of the moon. Calculate the escape velocity on the surface of the moon. Moon's mass is given as 7.34 into 10 raised to 22 kg, and radius of the moon is given as 1.74 into 10 raised to 6 meter, and gravitational constant, as we know, it is 6.67 into 10 raised to minus 11 Newton meter square per kg square. So these are the three things which we know. We know the formula for escape velocity. Escape velocity equal to root of 2gr. 2 small gr, but we are not having small g. Acceleration due to gravity on the surface of the moon is not given, so we have to use the previous formula. Escape velocity equal to root of 2gm divided by r, and substitute the values and find the answer for escape velocity. So 2 into 6.67 into 10 raised to minus 11 into mass of the moon 7.34 into 10 raised to 22, and divided by radius of the moon 1.74 into 10 raised to 6. So you can do this part first, 2 into 6.67 divided by 1.74, and then multiply this answer with 7.34, and then you can take the other terms separately. So 2 into 6.67 is 13.34, 13.34 divided by 1.74, you are getting the answer as 7.66. So what I have done over here, multiplied and divided by 100 to make it 174 and 667, since both the numbers is having decimals after two places. So this division, the answer you are getting as 7.66, 7.66, and then multiply by 7.34, multiply by 7.34, and the other terms you are taking as separately. 22 minus 11 is 11, 11 minus 6 is 5, so 11 minus 6 is 5. So this 10 raised to 6, when it goes into the numerator, it becomes 10 raised to minus 6. So 11 minus 6 is 5. So 10 raised to 5. For this multiplication, answer you are getting as 56.2. So 7.66 into 7.34 is 56.22, and so on. So we are taking up to only one decimal place, 56.2. Then multiply 10 to this 56.2. So you are getting 562. And then 10 raised to 4 remains at the side. So square root of 10 raised to 4 is 10 raised to 2, and square root of 562 is 23.7. Now how you got this? 20 square is 400, 21 square is 441, 22 square is 484, 23 square is 529. Means when you take this square to the other side, it goes as square root. So square root of 529 is 23. Then 24 square is 576. So if you can see this value, it's little less than 576. That means the answer for this is little less than 24. So then you can try 23.9, 23.8, 23.7. So 23.7 into 23.7 you are getting as 561.69, which is almost equal to 562. So this square can take the other side as square root. So square root of 562 is 23.7. So you are getting your answer as 23.7 into 10 raised to 2. Then you can multiply this, you are getting as 2370. escape velocity equal to 2370 meter per second. Now if you want to convert it to kilometer, divide by 1000. So you are getting as escape velocity equal to 2.37 kilometer per second on the surface of the moon. Next, weightlessness in space. The travelers or the astronauts who travel in the space on other heavenly bodies like the other planets or the moon, they feel like they have no weight, they are weightless, they are floating in the space. There are two reasons for this. First reason is the gravitational pull of the earth in the space is very less. It is just slightly above zero. So that it can be also called as microgravity. There is microgravity in the space. Because of this microgravity, the astronauts do not feel the pull from the surface of the earth towards the earth. So they feel like they are weightless, they are floating. Second reason is there is no other force acting on these astronauts. That means they are feeling like they are in a state of free fall. Only the gravitational pull of the earth is acting, that also very weak, and they have their orbital velocity. So they can be also called as they are in free fall. So space travelers as well as objects in the spacecraft appear to be floating. Though the spacecraft is at the height from the surface of the earth, the value of g there is not zero. Thus, the height of the spacecraft is not the reason for their weightlessness. Their weightlessness is caused by the state of free fall. That means they are in a state of free fall. Though the spacecraft is not falling on the earth because of its velocity along the orbit. So the spacecraft is having velocity along the orbit and the gravitational pull of the earth is also acting on the spacecraft. But it's very weak. So they are in a state of free fall because the only force acting on it is the gravitational force of the earth. As the velocity of free fall does not depend on the properties of the object, it is same for the spacecraft, the travelers and the objects in the craft. Thus, even if a traveler releases an object from the hand, it will remain stationary with respect to her and will appear to be weightless. So even if the astronaut releases something from the hand, it will remain stationary along with the astronaut. So this was the last part of this chapter. I'm finishing with the chapter here. So hope you have understood this part and the full chapter. If any problem, anything you didn't understand, then please leave a comment in the comment box. I'll definitely reply your question. So thanks for watching. Please subscribe my channel and please do like all my videos, share my videos. Thank you very much.